Welcome back, my dear students. This is video number 6, and this video is still in the proportions and ratios. But we will move to another part now, which is solving the equations of two variables. The two variables are x and y. How can we solve a problem of two variables, x and y? Let me go directly to the examples which I have for you today here. We'll go to the slide number 54 and take this one. Let us share the screen first to take the numbers from here and to show you what I am doing. Okay. Now the screen is shared, and I will take as example this one on my left hand, which is written in red. This one. X plus y equals 10, x minus y equals 7. And let's see how we are going to find a solution for it. I will just stop sharing now so that you can see the board properly. Then we'll move forward into example and we'll move then to the other example. Let us see how it will work here. Let's see how this will work. Okay. Okay, everybody. So x plus y equals 10. X plus y equals 10. This is the first equation. And now I will make the screen big. X, wait a minute, just be patient, please. Minus y equals 7. So far, so good. Now I will stop sharing so that you can see the screen. Okay, here it is. So those are the two equations, the two equilibriums which I have. X plus y equals 10, and the second one, x minus y equals 7. Let's see what we will do in those two equations. First of all, I have to get rid of one of the two variables. I have to get rid of one of the two variables. So I will get rid of the x or I will get rid of the y. I have here a good chance because in both the equilibriums, the coefficient here is 1 and the coefficient is here is 1, but 1 is not written. What I'm saying is it means 1x plus 1y. Here means 1x plus minus 1y. It doesn't make sense, no problem, but we don't write the 1, okay? So what we will do here, you can imagine now that I will subtract them from each other. Just subtract them. So when I subtract the second one from the first one, the plus, this is positive, will become negative, okay? And this negative will become positive. And this positive will become negative. Usually, when it's positive, it will become negative. And the negative plus, when you multiply it by negative, it gives you positive. And here, positive by negative, negative. Because we have rules for multiplying, which is, when I say the similars are always positive. So plus by plus will give me positive. Also, minus by minus will give me positive. And the opposite, when they are different, they give me negatives, like minus by plus will give me negative. And negative, positive by minus will give me negative. So the similars will give me positive, and the difference will give me negative. That's fine. Now, how we will find a solution for this problem? We said this positive, it will change into negative, and negative will change into positive, and positive will change into negative. Okay. Now, x minus x, look at this. X minus x will go with each other. Then, I will have here 2y's. Actually, this is 1, not 10. This is 1 in the example. It's 1. It's 1, not 10. Sorry for that. So those two will be 2y, because 1y up and 1y down, 2y equals minus 6y, minus 6, because 1 minus 7 will be minus 6. 1 minus 7 will be minus 6. Then if I want y only will be the far on the near, the far by the near. So the far is minus 6, by the near is 2, will equals minus 3. So now I got the y for minus 3. Minus 6 divided by 2, this 2, because I said minus 6 by 2, the far by the near, it will give me minus 3. That's fine. Okay, now I want to substitute to have the x. I didn't get the x yet, so I have to substitute to get the x. How I will do this? Simply, it's very simple. I will go like this. Let me check what is the, yeah. I will do it here in this part. Sorry, the board is small, I know, but it's like this under control. I will bring another board here, but for the moment, this will help. Okay, now let's say minus 3 here. I will work on this part of the board. I can substitute in any equation of those two equations, in equation 1 or in equation 2. I can substitute in any one of them with the value of y to get the value of x. Okay, now I said x, let us take the first equation. Let's take the first one. X plus y equals 1. This is the equation. We didn't do anything. X plus y equals 1. That's fine. Okay. I don't know the x. I know the y. I have the value of the y. That's fine. So x plus, we have the y with minus 3 plus minus 3 equals 1. X plus minus plus x plus minus 3 equals 1. That's fine. X plus minus 3 equal 1. That's fine. Okay. Now, x plus by minus will give me minus 3. X minus 3, because I multiply this positive by the negative. It gives me minus 3. X minus 3 equals 1. That's fine. Till the moment everything is good. Okay. Now, how I will get the x alone? Usually, I will put the simples on one side and the numbers on the other side. Very simply, I will put the simple here, and then I will cross the border. I will cross the bridge, which is equal, and take the numbers into the other side. But switching minus 3 into the other side, when you switch a value from a side to another side, and you have the equation, when you pass this equation, as you pass the bridge, then there will be a switch. The minus will be positive. Minus will be positive. So I would say I will keep the x here equals, I will move the minus 3. I will move the minus 3 to the other side. 3, 1 is here, the 1 plus, because minus will be plus 3. This will equals 4. Then the equation is y equals minus 3 and x equals 4. Okay? Okay. Now I would say back, and you can substitute with to the x with 4 and the y with minus 3 for any equation. Let's see the first one to make sure that your solution is right. How it is, let us take the first equation, this one, the first equation. We'll say as example, the x is 4. Okay, let's go here. X is 4. Okay, plus y is minus 3. Minus 3. We'll see how much it is. 4 plus and minus means 4 minus 3 equals 1. That's right, because the left side is 1. That's right. Then I solve a right solve. My solution is right. Okay. Here I am repeating back this example. X, the same example, I'm repeating it back. X plus y equals 1. X minus y equals 7. The same example which we solved before, just I'm repeating it back. Okay. Now let's say here I will subtract the second equation because I have the variables x plus y equals 1, x minus y equals 7. So I have both the variables x and y are same. Even though if they are not the same, I have to get rid of one of them, either for solving the equations. The first step to solve any equation is to get rid of x or get rid of y. That's what I'm doing. So I will say I will get rid of the x. How? The second equilibrium, this one, I will put it in opposite signals. So the plus, this is plus, will become minus. With the green, I will do it. Minus. And minus will become plus. And plus will become minus. I think it's clear like this. The plus, this is plus, but it's not seen, became minus. Minus became plus. And plus became minus. That's fine. So now x minus x, they will go with each other. Still for me now, y and y plus y are 2y, they are 2y, equals 1 minus 7 minus 6. Then I want y only. 1y equals the far by the near, minus 6 by 2, which will equals minus 3. Okay, I got the y equals minus 3. Now the second point is, I knew now that y is minus 3, but I just want to get the x. I can substitute with the value of y in any one of the two equations. Let's take the first one. X plus y equals 1. Okay, x is unknown, still unknown variable, plus y is minus 3. X plus minus 3, x plus, this is plus, minus 3, because y equals minus 3, that will come to 1. Then x plus and minus will give me minus 3 equals 1. Then I want the variable on one side and the numbers all on the other side. As long as I will move this digit, it will pass the equilibrium mark, the equation mark. As long as it will move to this bridge, pass this bridge, then the minus will be positive. You have to switch the signals when you move from a side to another side. But if you are still in the same side, you don't change the signals. You change the signals positive into negative and negative into positive only when you are moving or passing by the equation, this equation. Then x will equals 1, which is here. Then minus 3, we said it will be positive 3. Then x will be equals 4. X will equals 4. Okay, that means now I have y minus 3 and x equals 4. That's fine. Then in this case, I can substitute in the first one to make sure did I do the question right or wrong. Then I would say x is 4, okay, x plus y, let us make it large it like this, x plus y equals 1. Let's see, am I right or wrong? X was 4 plus y was minus 3. Let's see the result of this. 4 plus and minus 3 equals 1. Yes, 1, exactly like what he gave me in the equation at the start itself. So that means my solution is right, that the y minus 3 and x is 4 is right for the two equations. Again, I would say the process is to get rid either from x or from y by any way, like we'll see in the second example now. Then after this, we will get rid of one and get the result of that one. Then we'll substitute in the equation, okay, to get the other. And that's the way it works. Thank you. Okay. Let's go for the solve for this problem. We either finish the first one or the second one. I mean, we let the x's like each other or let the y's like each other. So I will select, maybe everyone is having his own way. I will select the x to be like each other. So I will multiply the first one by 3. Multiply by 3. Okay. Then it will be 3x minus 9y equals minus 36. The second one is still 3x plus y equals minus 6. Look at this. The problem is it does not mean that I multiply the first equation by 3 that I have to multiply the second one. No, you multiply only one of them because you want the x's to be like each other. I want the x's to be like each other. Some people will say, let's do it for the y. It's okay. You can the most important thing is that x should be similar or y should be similar. Okay. Now I will check out when I do the solution. I will get here, this will be minus, this will be minus, and minus will be positive. So it will be 3x and 3x minus will go with each other. Minus 9y and minus y will be minus 10y equals minus 36 plus 6 will be minus 30. Then y will equals, I will complete it here in this part, y will equals the far on the close by. So minus 30 divided by minus 10, which will be 3. I got the y for 3. I can substitute in any equilibrium of both the equilibriums to bring the variable x value. So I have y value now, like I said, minus 10y equals minus 30, and then y will equals minus 30 divided by minus 10 equals 3. I will substitute in the first equilibrium, which is x minus 3y equals minus 12. This is the first one. Okay? Okay. Then x minus 3. Y value is 3. 3 by 3 equals minus 12. Then x minus 3 by 3 give me 9 equals minus 12. Then I will let x go to the other side. The number will go to the other side with a different signal, like minus will be positive. Then x will be minus 12 plus 9. Then x will equals minus 3. Then we have the y for 3 and the x for minus 3. So here I showed you how we solve the equation of the two variables equation problems and how to bring the x value and the y value. And this should be the end of the class. But before I finish this, I want to show some examples, and we'll go also for extra examples here and the proportions. I will make a video for some examples I want to say in the proportions and in the ratios, and like using the CPI, how to change the nominal gross domestic product into the real, into real, from nominal to real, GDP. And I will give examples also for the equations, for those equations. It might be more advanced. You might need to know it. I will give it in a separate video, the next one. But for the moment now, this is the one which I was just on resolution for it now. It's on page 55, on slide 55. You will find it, slide 55. You can train yourself. As example, let's see here. Yes, you have an example here. 2x plus 4y equals 6, 4x plus 2y equals 6. This is another equation. You can solve it by yourself. This is on slide 56. Don't send it to me, please. You by yourself train yourself, and you have the answers. You know how to do. Check your answer. How I'll check my answer? I will substitute in the values of x and y, which I deducted, which I got it, which I got the distribution by. Then if it give me 6, that means I'm right. You can substitute of your variables. Okay, so this is another one, and you will find a lot on the internet how to solve the problem. The one with the red, the handwriting, this is because handwriting must be misleading to you. You just go for the slides itself, no problem. The slides itself will be more clear and more better, and it's not with handwriting, so you won't make a signal wrong or anything like this. It will be clear. On page 59, you have a lot of exercises about this, how to do the equilibriums. And still, I want to tell you something before I finish this class. Just an idea before I finish this class. Let me tell you, okay, let me okay. Let me tell you, we'll suppose, please watch the board. Please watch out the board here. This was the figure of this example. Okay, how about if it was like this? Plus 12 equals 0. Make sense? No worries. We said the variables which x and y on one side and the numbers on the other side. So it will be like this for the first equation. It will be like this: x minus 3y, then equals, I will move the numbers all together on the other side. It will equals minus 12. Same one which you had before, the same figure. But I'm just telling you, if it comes in this way, then you have to put the x and y on one side and you have to put the numbers on the other side. But the second equation, no worries, it's the same, nothing has changed. Plus y equals minus 6. Okay, so in just a case, if you get the numbers with the variables, the absolute margin, we call it the absolute margin, a number without is not stuck to it, x or y, it's clear, it's a clear number, no y or no x beside it stuck to it, no, then you have to put the numbers after the equation mark. Okay, you have to pass the equation mark. Of course, when you pass, you have to change the signal from positive into negative, like you see here. Second one is the same, nothing changed in the second one. I hope for you that this was interesting, and I hope that you got the understanding for this class. Thank you so much, and we'll see you on the next video. Thank you. Hello, my dear students, how are you? This is the last part of the equations to solve an equation with two variables, x and y. But I will talk about a case which is very rare, but you just have to know it, just for your knowledge only. It's not a matter of exam. I'm not going to bring it like in a quizzes, but I want you to know it for your own self, because it's very important to know. Like as example, if you get a fractions in one of the equations, what you will do? Assume that we have fraction in one equation of the two equations, we have fractions. What you will do then? Let us see an example here. I had a small example just to show you the idea itself. Then we can move forward like this. Okay, let's see like this. Let's say we have two equilibriums. The first one, 1/3 x plus half y minus 2 equal 0. And I have another equation which is x, suppose like this, minus y minus 8 equals 0. I cannot make a solution like this because I said the x and y must be in a part and the numbers must be in the other part. So I have to pass these numbers 2 and 8 after the equation. After the equation, 2 must pass here and the 8 must pass here. Okay, but still I have a problem. I want to get rid of the 1/3 and half because it's a fraction. I can't work like this. Okay, let's see, take the first equation, this one. What we will do in this equation, first we'll move the minus 2 into the other side. Then it will be 1/3x plus half y equals 2. Because I shift the minus 2, it was minus. Then I will shift it with a positive. So minus, when you pass the equation mark, it will be positive. That's the way. 1/3x plus half y equals 2. And the other equation will be the same thing, like x, this is what this one, x minus y will equal, because I will remove this minus 8, I will shift after the equation. So it will be 8. Still I have a problem in the first equation here. This one, we still have a problem, which is the fractions. I will take the common factor. Then what is the common factor here? The common factor is when you multiply the denominations in each other. 3 by 2 will give me 6. Okay, let's see like this way. Here, I will do it here. So 6 by 1/3 will equals 2, because this with this will give you 2. 6 by 1/3, 6 here. Because I will take all, multiply all the equation in 6. Why 6? Because 2 by 3 will give me 6. When I multiply 2 by 3, it will give me 6. So 6 by 3rd, 6 by 1/3, again, here, 6 multiplied by 1, 3. This with this, it will give me 2. Okay? Okay. So this will be, the first one will be 2x, okay, plus, when I multiply 6 by half, 6 multiplied by half, it will be like this. 6 multiplied by half, then 6 with 2, it will give me here 3. So here will be plus 3y equals, as I multiply the first part of the equation in 6, I have to multiply, it's like the scale, So I multiply one part, I should have to multiply the other part. 6 by 2 will give me 12. This is the first equation. Second equation, there is no problem because I don't have fractions in the second equation here. So I will shift the second equation, x minus y equals 8. Then what? Then you will solve it like you solved the other ones before. We talk about them. You will assume once you will put them together, make the x's like each other or the y like each other, then substitute with the value of it. You will continue like any other example we gave before. Okay? So I'm just saying the idea, how to get rid of the fractions of those fractions. It's not a question target. However, you should carry on and be very aware of what to do or how to get rid of the fractions. Thank you so much.